back, everybody. Today's video is it's not a long video, but if you remember, if you go back to my last video I did on the V8 Lego engine from Temu that my grandson built for me, and he's made a fantastic job of it. I did the video on it, showed the engine, and yeah, I really like what he's done for me. But I can't just sit the engine on its base without some sort of plinth, and I said that I would machine, to show a little bit of CNC work and that, and a bit of laser work. I would make a plinth, and that's what I'm going to do. I'm going to make it out of oak, American white oak, because I've plenty of that. The base will be made on the CNC 4040. It's not a particularly hard job to do. In fact, you can't get any real easy machining on the CNC than to make this plinth. I'll go through the steps on the PC, on the software, and I'll show you it being machined. I will be finishing in a coat of lacquer and then wax, and then I'll show you a little bit of the engraving on the F2 on the little brass plaque that I've got for it. I felt I needed to do it and put the lad's name on it. The machining part is relatively simple. I'll show you on the Aspire, which is what I use for CNC work. Now the tool paths are relatively simple, really. The piece of timber I've got is a piece of flat, reasonably flat, I'll say. Yeah, it's a bit uneven, and I don't want to put it through the planer, which is easy for me to do. I'm just going to show you what I did to actually produce a flat surface out of a piece of timber, whether it's rough sawn or not, or it's been left for a while and it's sort of warped a little bit. So I'll be machining one side, the tool path will be just machined flat across, flicked over, secured down, and then it'll be reduced down to the thickness that I want. And I'm showing you the way I do it. It's relatively simple, and I'll be using a 12mm cutter. And then the next process will be, once it's been machined to the thickness that I want, I will be actually doing another tool path, which will be a pocket. That pocket will be cut out, and it'll be 3mm deep. That will enable the engine base to sit in that, so you can pick it up on the plinth without it sliding off. So that's that. And then the next step, the last one, will be to do a profile cut around and cut out the side of the plinth that I wanted. And I'll show you the tabs that I put on to hold it in place, of which you just remove, snip off, or cut off with a Stanley knife at the end, but it holds it in place while your cutter passes through. But relatively simple. In fact, you can't really go any simpler for tool paths on a CNC really than what I'm using. And this is one of the things I've had a lot of feedback, and when you look at what a lot of people are putting on some of the sites, the forums for the 4040 or whatever other CNC, the Fox Alien, they've got a CNC and they're planning on cutting aluminium, they're planning on doing all sorts of fancy work. All I can stress, if you are new to CNC, you don't know about feed speeds and depth of cut and cutters to use and this and that, please start off with something simple. This is ideal. What I'm doing, it's a simple, really 3 different types of tool paths. Because people, and I've seen it, people are making really bad mistakes and breaking cutters and various other things, and destroying the material that they're using because they don't understand. They haven't learned enough to proceed safely. And they do bite, these machines, trust me, whether it's in your work, your cutters, or your fingers. So please be careful. And you know, the old saying is, don't run before you can walk. Please take it step by step. and the reason why I'm doing this plinth is just to show you simple toolpaths of what you can create. Okay, so what I'll do is I'll take you down into the workshop and I'll show you on the PC first roughly what I'm doing, and then I'll take you over to the machine, and I ain't gonna go following it all the way through, so it's just to show you what you can do with 3 simple toolpaths. Okay, so let's get down into the shop now.
Right, here we are at the PC. We've opened up Aspire, and as you can see on here, it's pretty simple. You can't get any simpler than this for a bit of machining. And what you've got here is this part here is the actual job dimensions. Okay, now the problem with me is this I wanted it to finish at 18mm, but it was different all over. There were corners up, there were corners down. So when I machine it, I actually have to make sure, and it were 21 in places and down as little as 19 point something in others. So, but I didn't want to go below 18mm, and that I stuck at that. So what you do there is I had to do a surfacing. So ignore these boxes here because that's my actual job. That and that is my actual, that's a pocket, and this is a profile with tabs. I'll explain that in a moment. But this here is just a rectangle drawn round. Doesn't matter how much over it goes in that respect, because I'm using a 12mm cutter to surface it. Okay, now I had a bit of old timber, so it was cut out of here in L shape. There was a square peg over here, there was a square cut out here, so I had to make sure it would cut it out exactly where I wanted it. So what I did was I needed to surface it, so I drilled a couple of holes so in the waste part that I knew I wasn't going to be used, and made sure that I screwed it down. And what I did was I put a little packing under the corners, because these 2 corners here and here were touching. This one however wasn't, so I picked the best side, so I packed these 2 and then screwed it down here. Okay, I then proceeded to draw a box round, and that was my machining, and I just did it as a pocket. This here is the first one. Okay, now you can see there I'm doing it 0.2mm, which isn't a lot for a 12mm cutter to take off. It'd take off a mil easily, but I didn't want to do that because I've got to try and give myself a level surface first. Okay, so I did that, and it's a 12mm end mill. Okay, and 0.2 is the depth of cut that I want. Okay, so I picked, when I took it off, I pick a corner that's upmost, the highest one. Okay, and I touched off on that, round about that anyway. So I knew my depth would start there. Right, what I'll do is I'll show you what this actual toolpath is. You can see it highlighted there, okay, which is the surface skin 1. Alright, so we're into the 3D view, reset preview, and then preview visible toolpath. You can see what it's doing, and because I've set boundary box, so to speak, beyond the dimensions of my material, that it just goes past it. So I did that, but I knew that wouldn't be enough. Now I could set, as you can see there, there's ever so many, there's 6 actual passes. Some of these are for the other side, of course. So once I've passed that on there, I'll show you that, where there, it's gone right across, okay, to there, so the cutter goes over the edges as well. Once it's done that, then all I do there is go there, duplicate. Right, now when I duplicate, I'll show you what it comes up as. It'll come up and it'll duplicate that toolpath, and all I do, because I've done it at 0.2, when you duplicate it, this is what you'll get. The first layer was toolpath was 0.2, now it's 0.4, so it's gone up another 2, but you've got to remember is we've already machined 0.2 off. Okay, now you could do all this in one go, but I needed to know when it became flat for me to turn it over and then work from the other side. You could end up, oh yeah, it's going to be so and so, it's going to be so, and end up taking too much off or not enough. This way you just run each one and you know at the end of it, because it'll put some pencil marks on, so you know when those pencil marks come off it's actually level. So I did that one. Okay, close that one, and if you look, take that off there, and if you look at this one, edit this one, it's 0.6. alright, and so on and so on, and that's all you do. It's pretty simple. So you end up with a flat surface. Then what you do is, because remember we've screwed it down, we've put some holes in here, countersunk them, obviously you need them countersunk because you cut a lid, and you flick it over, you countersink the holes from the rear, and you put it back in exactly the same position as before, so that your job 0 is the same. Okay, and I'm going from this corner. Alright, it doesn't matter about the box, I'm going from the corner of the material. So I put it back, screw it back down. Okay, and I've got a flat surface then. So then, because you've actually surfaced it, when I turn it over on the last one, which was the 0. If you look, 0.6, alright, what I did then was created another duplicate, and you'll see what it is 0.9. I increased it by 0.3, so it just, because it's already run a thickness, so it just machined it across again. It did a lot of it, but not all of it. So then I had another 2 to do, edit, so you 0.2 again, close, and then this one finalized the pass, 1.3. okay, so all I've done is increase the depth by 0.2, barring one which was 0.3, and I ended up with a perfectly flat piece of material at 18mm, and I mean bang on 18mm. So for me that was quite good. Once I'd done that, I removed those tool paths off the chip, because you no longer need them, and you don't want to clutter your chip up because it's only a 1GB chip. So the next step is to machine the pocket, okay, which is that one. Well, I was using a 6mm cutter, so end mill again. So all you do, and I'll show it on the video, is you move the machine over because it's gone back to job 0. You put a 6mm cutter in, end mill, and you touch off. On here you move the machine over till it's over the material and touch off. Okay, you've already got your job 0, and it was near enough. It'll be the, because you don't forget, you're actually trying to find the centre of a 12mm cutter, which is sometimes quite difficult, but it was near enough, because you have a little bit of waste there and you have a bit of waste there, and then all this is waste, so it worked out fine. Touch off, and then this is the pocket program. Toolpath, I'll show you that one. This is the pocket. There you go. Alright, and I'll show you what it entails. Edit. Right, it's a 6mm. I've chosen my 6mm, and it's telling me it's going to, I want the depth to be 3mm, because it's obviously set. You've already got your touch off probe. It's showing you the height that it's going to be, your depth is going to be 3mm, so it's going to do it in 2 passes. That's because if you look at your cutter, pass depth is 1.5. okay, so it works it out for you, and it's going to be 2 passes. Now what I've done there is it's going rastering again, but what I do at the end of it is I do a profile pass, so it will go backwards and forwards right the way across, and you'll see it leaves little bits because it's around there. It can't give you a neat because of the overlap. So then what it does is it'll come back over and it'll run a profile all the way around and clean it all up, and it'll do that obviously because it's running passes of 2. It'll do the last profile cut on the last pass. Okay, and that's it. That's for your pocket there. Right, the profile, this is, and in fact I'll show you on the you can see what it does, and if I slow it down even more, see about there, if you watch it there, and then it'll go around the outside. It's hard to see, I'd have to slow it right down. Right, so that's what you end up with. And you can see the profile there. That's the profile pass, and that's where they go to. Okay, so that's that one. So I've done the pocket first. Let's go back to the 2D finish. 2D view. Let's go back to the 2D view. Right, so we'll get rid of that one. Now we're going to do the profile. Okay, so I'll show you this one. Now you see there, there's 6 little squares. They are tabs, and it's got a T in, tabs. Okay, now because the material was 18mm, I did touch off again on here to make sure, and I touched off on quite a few and there were very little discrepancies in it. So I wanted it to cut through, so I did it at 18.5. I needed to cut down, and I was using a longer profile 6mm end mill because obviously it has to have the cutting face on of 18mm, so you want a little bit more, and it's going just slightly into the spoil board. Alright, so I've done, and it's on the outside of that, okay, which I want, and it's selected, and its passes is 13 passes because you're doing 18.5mm, and if you look at your cutter it's only 1.5mm. okay, so it calculates it needs 13 passes to do what it's going to do and cut through. You go down to the tabs then, and you can see, and when you go on to the tabs, add tabs toolpath, okay, edit tabs, I can take away a tab or I can put a tab on. Doesn't make any difference. It's pointless putting any on at the side because there's no tabs to fasten it to, so I've put 3 at the end and 3 there. Alright, now I'll show you. Okay, I've had to calculate that again because I altered one of the tabs. Right, so I'll show you what this is, and this is a profile. Reset preview. You can see what it's doing. Those are the tabs. Okay, now what that will do is that will steady and keep that material in one place while it's machining, and it only takes a fine piece off or fine bit of material off on the last cut, so it's not a great deal till it relieves the stress of the cutter on the material, especially the centre part, the job that I wanted. Alright, so that's your tabs, or those are your tabs, and then all you do is you can see what they're like. I'll whip it round to the side, you can see them there, and all you do is just cut that off with, I'll show you on the machine actually when it's finished, but you just cut them off with a standing knife and a little bit of sanding and the job's done. Okay, so that is the program and the toolpath. As I say, all these for each side, I could do one toolpath that would take me down to the depth I wanted. Unfortunately, I didn't want to take too much off, so and not only that, sometimes I like to see the machine working. So what I did it in stages, 0.2, and I took it down and I got exactly 18 mil, what I wanted, from a piece of timber that was quite badly warped, and it's perfectly flat now. So okay, now that's the software and the toolpath that I used. So what we'll do now is we'll go over to the machine and I'll show you the toolpaths and I'll show you them working. Okay, right, here we are at the machine. I've got a 6mm shanked 12mm 2-spur cutter in. That's sufficient for this. This is the job for the plinth for the, and it's out of oak, it's plinth for the engine that my grandson made me. Now this was quite uneven. I've run one pass, just take 0.2 of a mil off. It's running at 12mm cut, it's running at about 12,500 RPM, thereabouts. It's fast enough for 12mm cutter. I can turn it up if I want, it's quite well balanced, but I've just done one pass, and all it is a surfacing pass, and what I will do with that is, once I'm going to surface it again with another pass, and all I've done, and I will show you the tool paths, is I've done 3 tool paths, and I've started off, this is just trimmed 0.2 off the surface, and then the next tool path will be the same tool path, but it's 0.4. okay, so that just takes it down another 2 mil, okay, because you've already set your 0, which is to the surface of the original timber, so it won't go down and do 0.4, it'll take just another 2 off, 0.2 off, because you've already taken 0.2 off. Okay, what we'll do now is we'll load the next tool path. Okay, so it's from the storage, go on to the next one, and it's the surface skim set 2, which is that one. Okay, select the G code. I do it always, but I'll do it for you this time. Generate toolpath graph, and if you look at the map, you'll see it there. That's what it's doing, just rastering across backwards and forwards. Okay, go back to file, start the spindle up. Okay, and we'll press start. Point 2's allowed, rather a mild skim, but it's ample for what I want. And you can see, because this is trammed up, you'll see there's no other lines, and it's a 12mm cutter. It's really simple to do if you're surfacing out. Once I've done this surface, then it'll be flicked over, and then I'll do the next one, which is surfacing past 3. And if that doesn't take it down to what I want, I'll just do another, just copy the tool path but increase the depth. It's just the way I do it, and I find it really works well, and it's simple. All you're doing is duplicating the tool path for surfacing and just adding another point, whatever you want on. You know, it could quite easily take the mil off, 2 mil off with this, but not a great believer. I've said in other videos, pushing machines to the limits. after this path, I will turn it over and we'll do the third pass. It's picking a lot up is the actual dust extraction, but I've got a 12mm cutter on, and I should have really put the longer brush on, but it doesn't matter, I can change it for the next tool pass. You can see that how smooth that is, and you can see the lip where it's cut into there. 0.2 it's taking off. I don't want to take too much off because I want it. You've got to remember you've got screws countersunk in there. Right, we'll leave it at that and we'll come back. Oh, what we'll do is I'll show you the map. There, can you see it? See the little yellow line moving backwards and forwards? That's because I've mapped it for you, but I do not normally do that, trust me. I don't need to see that, I know it's doing it. Some people like to view it and like to view it on the PC, I do not, I'm not bothered. So, okay. Right, here we are at the machine now. It's done that second tool path. So I'm just going to move the machine on its y-axis back, that's all. Okay, don't worry about thinking you've lost your job position, because as I've explained in a lot of other videos, you don't lose that. When I leave that there now, I've just switched the MPG controller off. When I switch that off and leave that machine there, I can turn this over, screw it back down, put the next tool path in, and it will come back to the job origin and start from there. Alright? You'll see anyway. What I've done there is just countersunk the screws. You've got to remember that. You're surfacing and you fasten it down. This is in the waste bits. The part I'm using is going to be there. Okay, so I've got a line to work to and an end line to work to there. Okay, put that in there. So all I do now is go back to the file. I told you, if you watch, that will move back to job origin. Doesn't matter, I've moved it, but it doesn't matter because it always goes back to the job origin to start. Right. Load toolpath, storage, next, and it's the number 3. Okay, select this code, generate toolpath graph so that we can go to the map. Wouldn't normally, but I have done for yourselves. Okay, and then start the spindle up. And then we just start the toolpath. Start the vacuum. See how it's coming back to job origin? Now you can see, if I show you, how uneven that piece of timber was. It's completely flat on one side now. I flicked it over and then I'm just running this. Now it's not catching it, it's not touching here, but I'm not bothered about that. It's here, from here, that's bothering me, because that's where the part starts from. So I will do another duplicate toolpath and I'll show you all the toolpaths. Map, there we go. Okay, just going to let this run and then we'll have to do another toolpath. Okay, which will be number 4. Now I could have done all this in one go and just had it step down each time, but I didn't know how much I was going to have to take off in order to make it level, and I didn't want the material too thin. So I always find best to surface it. If you clear it all in one go, fine. If you don't, take the minimum off each time, because that's oak and I'm not wasting it. You know, you take too much off, but I need it a set thickness. But yeah, it's easy just to, I can check it after every toolpath, and if it is, I just run another one at a different depth. Most people would probably, and I do sometimes, I'll run it all in one go, so it drops down 0.2 each time to the depth that I wanted. Okay, but you don't get to know how to use a machine unless you program it and do your toolpath, then you know. Okay, we'll come back on the next toolpath. Here we are. I've just loaded the next toolpath. As I say, you can just see it's proud there and it's proud at that corner there, because that's where it's machined it off. Okay, so I just need to flat it a bit more. I've got another 2 toolpaths that I can do, but as I say, you can put all these in and just do it in one pass, because it'll just keep moving it down in it's just one toolpath where you increase your depth. You set your depth and it'll decide on what you're taking off, whatever you set, it will tell you whether it's going to do it in 3 goes or 4 goes. Alright, but I like doing it this way. I see the surface appear and I know when not to take any more off. Okay, machine's running, I haven't switched that off, and I'm just going to start the toolpath. You can see there, it was here and it's there. Okay, so probably another toolpath. We shall see. We'll come back when it's finished. I can't express enough what a difference this screen, which I've done a video on, makes to the use and operation of this 4040. Yes, I had the Sainsmart's offline controller, but as I said in previous videos, I had whiteouts on the screen. Still ran the program, but I couldn't do anything with it. So, and if I want to, as you say, look, it's a fantastic extra item to use with the MPG, is this screen. I was going to get the wireless touch off, but I like the idea. Now I will get the Nymo Labs wireless touch off. Sainsmart, it's virtually the same actually, it looks the same. They're a little bit expensive at the moment, like I think they're about £50. But yeah, I think I shall get one of those. And you can see the spindle. I mean, it's great watching this, but who wants to watch a cutter go around? I can see what it's doing, but it's not everybody's choice. That's my choice. And as you can see nicely now, machining right across on that side. Yeah. There's just a little bit more here, so one more pass and then that's going to be it. As I say, I want this as thick as possible. I could have done it in one tool path made up of so many passes, but you might end up thinking, oh wait a minute, it's doing another pass here and I don't need it to. The beauty about when you do it like this, individual tool path, is you can see what it's doing and you know that if you have to alter anything you can do. There we are, and you can see how close I've got it. It's skimmed across the top of the pencil mark. It's machined it, but because they're quite in. Here we are now, and as you can see there is no pencil marks. The finish is superb. There's no step overs, nothing. And that's because the machines, I actually tram the machine up, so even if I put a wider cutter on, it still does not leave marks. Okay, so I'm happy with that now. I'm happy with it, and I've got the maximum thickness out by cleaning it all up. There you go, job finished. This part, if I had a piece of material that I was happy with, that was planed up and everything, I could have just run the actual tool paths for the cutouts of the pocket and the profile, but I didn't, so I've had to plane a piece up, and I didn't want to get the planer out, so I was just showing you what you can do if you've got an old bit of timber. That's come up really well. Okay, and turn the motor off now. So we'll get on loading the next cutter and tool paths. Right, I've loaded the pocket tool path, which will create a pocket in here for the motor, the engine, to sit into. Okay, so it doesn't slide off. I've loaded the program. I've changed the cutter for a 6mm cutter. Let's see what this does now. And I've touched off. Now you can see there it's creating the pocket. This is only 3mm deep, it isn't a deep pocket. But as I showed you in the previous videos, when I machined the base for the Xtool F2, that it does the machining, rastering from side to side, and then it does the last, you set it which way you want to do it, first or last, and then it'll do a profile around the outside, so it cleans that up. And as you saw there, from the when I started the software program off again, all the toolpath, it was right back because I changed the cutter, and then you just, doesn't matter because you've already done the job coordinates, so 0, 0 point, so you just put another cutter in, move to a point on the material, touch off, leave it where it is, load your toolpath, send it, and it'll run it and go back to job origin. Now because I had a surfacing job, that didn't make the difference, because I was centering on roughly a corner for the job origin. When it went back, I found that I needed to correct that by a couple of mil, so I just corrected the job origin, zeroed it off again, and there's not a problem. It's getting to know what you can and what you can't do. And as you can see from that pocket, It's machining it out quite nice and neat. Taking most of the chippings up, but not them all. It isn't the best of vacuum cleaners that I have. And this is 3mm, it's going to be done in 2 passes. So I'll move back and start again. Go to the map. There we go. Now you can see it's running a profile around the edge, and I prefer to do it after, not before, but it's everybody's choice. And you can see that on there. Go back and it will plunge in the final amount. It's just rastering now. It tells you in the software how many times it's going to have to run it. You can alter that if you want, depending on how much you're taking off with the cutter when you set it. But this is doing it in 2 passes. We'll come back when the job's near complete there. And here we are. It's done its final pass. So it's making those edges nice and crisp. Obviously you've got it's a 6mm cutter, so you're going to have a round in the corner. But that's fine. Completed. So what we're going to do now is we'll load the next toolpath, and I will show you all the toolpaths on the computer, but we'll load the next one, the final one, which leaves tabs on, and that enables you to, for the piece doesn't float and it kicks it to one side, it holds it in place. There's 6 tabs, and you'll see them, so we'll get on with that. This is now doing the final cutout. And when this gets to the bottom, what it'll do is leave tabs on this end and that end, and all being well, it shouldn't come loose. I believe on this, and it's American white oak this, I believe the program set it had to do it in 12 passes. It's 18, I took it down to what I wanted, which was 18mm, I didn't want it any thinner. What you could do, instead of leaving tabs on, is you could put double-sided tape underneath it all, and then when you cut it out you just prise the centre part off. But I wanted to show you what it's like with tabs. You'll see when it's doing the tabs, because it lifts up, see it slows there, because it's doing the tabs. Another one. Another one. There's 3 in each end, okay? And it builds them up. You set it in the software, but of course this is Aspire, so not everybody's got that. Oh. And it's building up. You set the length of the tab, the thickness of the tab. There's none downside. It's not quite through there, but it will be, because I set it 0.5mm over. Now you can see that's through. I don't know whether you can just see in there. I'll show you the tabs afterwards. Kick that out because it's loose. Okay. And you can see the dust boot working properly there. That's it. Job completed. Turn the cutter off. Turn the back off. Now what I was going to do is put a slight bevel round here, and you can do that on the machine. You just put a V-bit in and run it again, set your depth, and it'll put a bevel on for you, but I'm not going to do that. It's a bit pointless. It's a pretty simple procedure, so all I'm going to do is just put a little bevel on with a nice little block plane. So right, I'll get this out of the way. You'll see where the tabs are when I unscrew it. See? Right, you can see, look, it's held on with, you see I'm moving, let me take this screw out, you see I'm moving that and I'm moving that, and you can see what it's cut through, but if you look, let's move that and move that over there, you see where the tabs are. There's 3, okay. That one came off because I had an idea that would, because it was on an off-cut piece, but I still put 2 in, and it still held it. And if you look at the pieces now, can you see the tabs? That's what the tabs are. There you are, and you set them. Okay. So what I'm going to do now is I'll break these off, cut the tabs off, and then that job's done. You can go around it, it gives you a nice, this is where the 3D printed sanding blocks came in. Right, so now there we are. The engine sits in that, and I've got a brass plaque to put on there. All machined from a bit of rough oak. I will show it in a close-up because I'm going to finish it. I'm going to put some lacquer on it, and it's perfectly straight. There you can see, machine perfectly true, cleaned up, all square, all nice and neatly cut out. Just put some wax on that and see what it looks like. I'm not going to stain it because I like the natural look of oak. Okay, so that's that job finished. Alright, here we are at the machine. The software, obviously Xtool Studio. I'm using the F2 and it's a highly reflective brass coated plaque. Now no one knows what it's going to engrave like until you've actually done it. Now what I've used is actual, I've set it up, focused it, I've peeled the protective layer off the tag, and I'm going by, if you look at the settings up here, mode it's processing on base plate, glossy brass thing. Now what I've selected there is actually one that is in the software, and if that works that's fine, if not then I'll have to make alterations. It is using, when you look here, it is using the infrared laser, as you can see there. Okay, yeah, I mean you can alter that, but it's using the infrared, so I've not used that before, so we'll see what happens with that. It's all done. I want the outline, as you can see in red there, it's the lettering and then the outline in red. It's doing two different moves. It's doing the layers, it's actually doing the engraving of the letters first, and then it's going to do the outline or the box last. And I want the outline not to be as prominent as the letters. We'll see, it's all trial and error. So the machine set up, the extraction hose is outside, and we'll see where it goes from there. I have framed it and it's right, but we'll see what the result is. I have some, they're only reasonably cheap of these, so if I don't get it right on this pass, which a lot of the time you don't, unless you've done it before, so it's trial and error for me. I've never used the infrared light, so we'll see what goes from here. So I'll put on the processing, and then as you can see there, that's what it's, and then all I'll do is start. You can see it set up in there, and you will see it doing it. I've sent the information now to start to the machine, and all I have to do is press the actual button to actually complete the task. So fingers crossed, let's see where we go from here. Very quick. I'm anticipating now what it's going to be like when I lift it up. Let's see. There you can see that. Yeah, I'm over the moon with that. It's just how I wanted it. Yeah. And yeah, I am pleased with that. So that's a simple process. It just goes to show what a different laser can do. I might put one in, do the same, but use the blue laser and see what that does. But yeah, I'm chuffed with that. So job done. Let's see it on the finished item now. Right, here we are now at the finished item. That's the model, the V8 model, and the plinth. Simple plinth, but it just goes to show what you can do. And you can see the engraving.
Yeah, it now looks the part, and if you look, the engine cat, it can only move within the pocket, so that enables you to pick the plinth up without the engine part sliding off. So yeah, once again, Jack, thanks very much. Right, well, that's it for this video. I'm sure it's a simple, the engine wasn't simple to build, I can assure you on that one, but my grandson did that, Jack, and I thought I can't just leave it sat on the top inside my cabinet or somewhere else. I said it needs a plinth doing, and so I've done that. I've shown you the simple steps of making it from a piece of uneven American white oak. I've shown you the machining involved and everything with that. Pretty simple, straightforward as regards CNC work, and the engraving on the F2. It was new to me. I've used the diode on it before, the blue diode, but I've never used the infrared. I used the standard settings that were in Xtool Studio, and they worked a treat. And it's a brass plat. I did get some stainless steel ones to see whether that would show up better, but as it's got gold inside here, and sort of polished brass does show up well on the oak plinth. So yeah, chuffed. It will be Jack's one day, I'm sure. I just wish I had one of these sat in a car somewhere, but never mind. So that's it for this video. I hope you've enjoyed it. Don't forget, like and subscribe. It doesn't cost anything, and it does help my channel. I'm moving along, but very, very slowly. And everything I do and everything I use, I pay for myself. I don't get sponsored by anybody. So if I want something, I have to save for it. Unfortunate, but that's the way it goes in this day and age. But yeah, and as I always say, until next time, you be safe, you be careful. Bye for now. Until the next one. Bye.